So when you create an array of size n, okay, so n is say 10 integers. So you are going to have the array index from 0 to n minus 1. You should be familiar with that. Now, of course, those elements, say if you're storing integers, you're going to be stored in some part of the memory. Okay. Now, one thing you have to understand is those integers or whatever the array elements are, they are going to be stored in consecutive blocks of memory. Okay. And we'll use integers as an example here to work out this illustration. So here I'm storing an array of say n integers, and so once you say it is an array, it's going to be stored in consecutive blocks of memory. Okay, so what I mean by consecutive blocks of memory, so you know things are to be stored in memory in your computer, and each of those locations have an address, right, where you store things. So this is the memory address. So it's represented typically in hexadecimal, but for ease of understanding I'm just using a decimal representation of the addresses. So address 200 is the starting address where this 10, the element at index 0, which is the first element of the array, is stored. Now you see the address of the next element is 204. So why is it not 201? Somebody may wonder like that. Any quick answer? Let me go back to the screen and see if somebody has an answer why it is 204 instead of 201 for second element. Okay. Alright, so you can tell over the microphone also if you want to. Okay, so we are working here with integers. You should know that any integer takes 4 bytes of memory. So this 10, even though it doesn't need 4 bytes to be stored, any integer that you say this is an array of integers. So once you declare that, each integer is allocated 4 bytes of memory. So each byte is represented using an address. So the 4 bytes of this element at index 0 are stored at address 200, 201, 202 and 203. So those are the 4 bytes. So the element at index 1 is stored in the next 4 bytes of memory. So from 204 to 207 you store this 23. Of course, if you don't have to you represent things in binary, zeros and ones, right? So most of those memory locations will be zeroed because you don't have to use all the 32 bits. 4 times 8, 4 bytes, each byte is 8 bits, 32 bits to represent 23. So most of them will be zeros, but still you use up all those 4 bytes. So that's why it is. So the next integer will be allocated these 4 bytes starting from 208 and then to 211 and then 212 to 215 and so on. So this is how the array values will be stored in memory in consecutive blocks. Okay. So if you look at the code, for example here, when I say int star array equals new int array size, so you should be familiar with this statement from your earlier classes, but basically what I'm doing is array size is array size of the array, the number of elements you want to store in the array. We'll come back to this code in detail later, but right now in this statement what I'm basically doing is I am declaring an array of size array size. So this is our n here, and on the left hand side I say int star array. So this is called the array pointer. So the array pointer basically stores the address of the first element. So the address of the first element, which is at index 0, is 200. So this is what the array pointer, the array in that code, is going to store. This value is 200. So pointer, if you do not know before this, pointers always store memory addresses. So in this case, it's a variable, and a pointer is also a variable, and it's what value it stores. It stores the address of some location in memory. So this is 200 is the address this pointer stores. And this is like in 4 bytes, right? Because the memory addresses are represented also in 4 bytes. So the space allocated for a pointer, how much space a pointer variable takes up, it also takes 4 bytes. Okay, so that's some additional information you need to know. Now, any questions so far? Yeah, so the address is random. So I just came up with this number 200 just to illustrate the idea. When you run your program, the operating system may come up with some address. So yeah, so this 200 is the starting address which I just came up with. But once you fix the starting address, the rest of the addresses is following from there. So if it is 200 as the first address, the second element cannot be stored at 504 or 704 or anything like that. Once you fix a starting address, the rest of the addresses should be based on that. Okay, any question? Yes, the videos I'll be posting, I'm recording will be posted. Already I posted the lectures from the last week class, and also the Canvas recording, which I'm also doing simultaneously, will be available for 14 days from today. So both resources are there, and I am available for any email and any questions you have. And there will be 2 TAs in this course starting to work from September 1st, and I'll be posting their virtual office hours, and you can also discuss or ask them for any questions. Alright, so let us continue. So now if I want to access a specific element in this array, so when I say for example, if I want to access the element at index 2, so I want to say what is the element at index 2, and say for example C out A of 2, right? So how are things really accessed in the memory? So since now you know that the array values are stored in consecutive blocks like this, how is that value of element at index 2 fetched from the memory? So you may think that to fetch the value at index 2, the processor has to really scan through the array at element index 0, then index 1, and then index 2. So read it sequentially from left to right and then fetch the value. That's not the way it is done. Because think about it, if your array has 1 million elements, then to retrieve the value, just read what value is at the 1 million index, then you have to really scan through the entire array and then fetch that value. If you fetch like that, you are going to spend a lot of time to read the elements in the array. So the read operation, which is basically trying to see what is the element there at a specific index, is really less time consuming operation when we use arrays, and it is called theta of one time because it takes constant time to read any index in the array. And you may wonder how, irrespective of the index. So this is how it is done. If I want to access element at A of 2, all it is done is, so you see A of 2, this A is what? The pointer name, right? So like in the examples here, you say array of I, isn't it? So when you say array of I, this array is the pointer name. So the pointer stores what? The base address. So if I did not introduce the term, this is also a more technical term. The starting address of the array is also called the base address of the array. So when you say A of 2, you know what the pointer value is, which is 200. That's the base address. So this is the math you do, 200 plus that index, which is 2, times the size of the data type you are using here. You are storing integers. The size of integers is 4 bytes. So 2 times 4 is 200 plus 2 times 4 is 208. So right away, by doing a plus and multiplication, addition and multiplication, which is just 2 arithmetic operations, you get the address of the element at index 2, which is 208. So right away your processor can go to that address and fetch the value. You don't really have to do a sequential scanning of the array. So for example, if I want to access A of 9, all you have to do is the starting address is 200 plus 9, which is the index that you want to access, times 4. So the 9 is coming from A of I, the index. So 200 plus 9 times 4 is 236, and that's the address of the element, starting address of the element at index 9. And you can right away go to that address and read what the value is that index at starting from address 236. The next 4 bytes will be that integer. So this way you can read or access or fetch, whatever the term you want to use, the any element in the array in constant time. So why I say constant time, the number of operations you do, which is addition and multiplication, and you fix the basic operation, which is say multiplication is more time consuming than addition. So basically the number of multiplications you do is 1. You may even do 2 multiplications, but in this case is 1 multiplication for reading. The thing is, it doesn't depend on what index you are trying to read. To read an element at index 2, it's 1 multiplication. To read the element at index 9, it is still 1 multiplication. So that's what I mean by constant time. So it does not depend on really what index we are looking at. So operations of such time complexity, we can say it is state of one time. Okay. So just back I said you may even do 2 operations or 3 operations. The thing is, the number of operations you do, if it does not depend on the index or in general the size of the array, we can say it is state of one time complexity. So it's always, if it's the same number of times we do the basic operation, irrespective of the index, in this case for the read operation, it is state of one time. Okay, is that clear? Any questions so far? Okay, let me check what time it is. So we'll still have time. All right. Now we'll go through an example of arrays using objects, but this is something I want to put separately right away before we go through that code. So let us say we have a class called packet, and I'm creating objects of that packet. So let us say num packets is the number of packets I want to create as an array. So I'm creating an array of packets. Basically, how many packets? Num packets. That's what we have to understand from the right hand side of the statement. And as we know from integers, the same kind of logic is followed here. You create an array of integers, here you create an array of packets. And the address, you know by now, when I create an array of packets, this is how the packets are stored in memory. So this is my packet 0, which is at index 0 of the array. This is my packet 1, this is packet 2, packet 3, up to the last packet. So let us again use the address 200. So always it need not be 200, I just pick 200 again. So 200 is the starting address of this array. So that's my base address. And this packet array pointer stores that base address, which is 200. So what is the value of this packet array, which is a pointer to the array of packets, is 200. That's the base address, the starting address. So this is something you should understand. So creating an array of objects is same as creating an array of integers. Now one thing you should be careful, I said the size, the number of bytes you allocate for each element in the array depends on what you store in the array, right? So in this first example we store integers, so that's why each block, each element in the array takes 4 bytes. So the address is like 200, the next element is at 204, 208 and so on. Now in this case you're storing packets. So let us assume the packet has 2 member variables, which is the ID and data. So let us say the ID is an integer, which is 4 bytes, and data, let us say it is a double, real number. So let us say it is taking 8 bytes. So each packet is basically taking 4 plus 8, 12 bytes of memory. So that's why I represent here the first packet is stored at address 200. Once I fix that starting address 200, the next packet, which is at index 1, will start from address 212 to 12 because 12 bytes of memory. Then the second at index 2, which is the third packet, will be at address starting from 224. 12 plus 212 is 224. The next one will be this plus 12, 236, and so on. So still we can use this logic of accessing the element. So if I want to access the packet at index 2, all I need to do is 200 plus the index 2 times the size of a packet, which is 12. So 2 times 12 is 24. So 200 plus 24 is 224. So right away I can go to that address and access the packet. If I want to access the packet at index 5, all I have to do is 200 plus 5 times 12, which is 260. I can access the packet at index 5 right away. Is that clear? Any question on this? So this is something you have to understand how to use arrays with objects also. Okay. So let me save this video and then we'll